So the pancreas is primary an exocrine organ. So these big ducts are going to be carrying out enzymes that help to digest food, right? So pancreatic enzymes that help to digest proteins, fats, amino acids, that kind of stuff. But it also secretes two hormones, glucagon and insulin, that are important in blood glucose levels. So how much glucose you have circulating in your blood, and that is available for your cells to use, right? And so here you can see blood glucose levels and insulin. So as glucose goes up, insulin secretion goes up to bring it back down, to keep homeostasis, right? And this insulin allows a lot of your cells to get energy, especially like your muscle cells. And then glucagon does the opposite. If the blood glucose is low, then you'll release glucagon. It'll free up glycogen or glucose molecules from glycogen to increase your blood sugar. We are mainly going to be focusing on insulin. So your insulin has a couple different receptors. One is the GLUT2 receptors. These GLUT2 receptors are going to be the receptors in the pancreas on the beta cells, right? And they're going to accept glucose molecules, which is going to make ATP, which is going to influence these ATP-sensitive potassium channels, right? After that channel closes, calcium comes in. Calcium causes the release of insulin and amylin. This is going to be important later when we're talking about different types of drugs to treat like type 2 diabetes. So glucose in, potassium close. Oh, I have open there. Potassium close, calcium open, insulin out. We also have GLUT4 receptors, and these are going to be the glucose receptors that you find on your muscle cells, on your liver cells, and insulin will bind the insulin receptor and will cause these GLUT4 receptors to then come out to the membrane. So typically they're not out here being expressed until your insulin receptors set those off. You also have GLUT1 and GLUT3 receptors. These are going to be the receptors that you find like in the brain and the kidneys that let glucose in that way. They don't need insulin, so the only one that really needs insulin is your GLUT4 receptor. GLUT2 releases insulin. GLUT1 and GLUT3 bring it in, or bring in sugar. And then you have a glucagon causing glycogenolysis, the cleaving of glycogen. Alright, diabetes, mellitus. Diabetes just means increased urination. Mellitus refers to the glucose in the urine. So there's another type of diabetes, insipidus, which does not correspond with an increase in glucose in the urine. It's just frequent urination. About 90% of the diabetics in the United States have type 2 diabetes. This is your insulin-resistant diabetes. What's happened is the body has become desensitized to insulin. While you're type 1, this is autoimmune. These are going to be people who need insulin because their body is attacking and killing their beta cells or their insulin. Symptoms of diabetes is hyperglycemia. You have glucose in the urine, glycosuria. Polyuria, they're going to be peeing a lot, which goes with dehydration, and polydipsia, drinking a lot, and sometimes polyphagia, especially in your type 1 diabetes. Their body is destroying the fat and the protein, the fat and the muscle in the body to get the energy, and so the body feels like it's starving even though it has plenty of sugar. That keeps getting peed out. Ketoacidosis is something that can happen in diabetics, when the body breaks down all those proteins and fats, it can cause the blood to become acidified, which causes a loss of electrolytes, which can cause central nervous depression, coma, and death. Diabetic coma, right? Ways to monitor for diabetes mellitus is, one, you're going to check the blood sugar. Anything like 90 milligrams per deciliters is about normal for fasting blood sugar levels. When you eat, everybody's blood sugar goes up and then comes back down. The people that have diabetes, their blood sugar tends to be elevated even when they're not eating, right? Sometimes 300, 400 milligrams per deciliter. Another way to check people's blood glucose levels is to look at their glycated hemoglobin. This is the HbA1c. Some people just abbreviate to your A1C levels. Red blood cells don't have GLUT4 receptors. And so they don't need insulin to bring in glucose. If you have high levels of glucose in your blood, your red blood cells' hemoglobin gets glycated, gets bonded with that glucose. And so you can check blood glucose levels over about 3 months, the lifespan of about a red blood cell, by looking about how much of that hemoglobin is glycated. And it gives you a number like 7.1 is the HbA1c, right? Which means that person is diabetic. I think typical is around 5. But it allows you to check blood sugar over a much longer time, because somebody could be like, oh, I have a doctor's appointment, I better get on top of my blood sugar, and they spend like the last week being really good about their blood sugar, but the previous 2.5 months being terrible. The A1C would show that. So for treatment, type 1s, you have to get insulin, right? And then diet adjustments typically go along with that. Type 2, there's a lot of different drugs out there. Some of them can use insulin or secretagogues, glucose absorption inhibitors, biguanades, insulin sensitizers, peptidase inhibitors, sodium glucose cotransporter 2 inhibitors. There's a lot of stuff out there to treat type 2 diabetes. There's a lot of people out there with type 2 diabetes, right? So our insulins, primarily your insulin is going to be sub-Q. It can be IV in emergencies if somebody is like super big ketoacidosis in the ER, you can give it IV. Nowadays, it's all produced using recombinant DNA with these amino acid analogs. So your Novolog, your Humalog are going to be a little bit different from each other because they have these analogs that don't make the active sites different. The insulin doesn't work different, but the chains in the middle are different. So with your so these are short acting insulins, Novolog, Humalog, Prida, and then Humulin, Levemir, Lantus. These are going to be long-acting insulins. For a type 1 diabetic who doesn't have a support device like a insulin pump, they should be on both of these. And you would take a short-acting insulin at a meal to control for the carbohydrates that you're about to eat. And then you would also take a long-acting insulin in the morning to maintain your blood sugar throughout the day. These dosing regimens should be variable because your ability to respond to insulin changes based on maybe if you have a cold or if you're super stressed, you might need more insulin than normal. Or if you've been working out really hard, you might need less insulin than normal. And so a lot of these are varied. And that's kind of why Insulin pumps are really good because you can control, it's all short-acting insulin in those, and you can change it based on what you're doing. And then you have constant blood glucose monitors that you can team up with these things, and so you can really keep tight control on your blood sugar, which is great. Way to go, modern science. Alright, we'll pick up with type 2 drugs in the next section.